Hi everybody, my name is Yash Thapliyal, and today I will be demoing the product that me and my team for Codebase Spring 2026 were able to deliver. So this project is called Alloy Finance, and the purpose of this project was to demonstrate the AI capabilities of AlloyDB, as well as its ability to host AI workflows. So what we decided to do was implement a finance platform to demonstrate AlloyDB's ability to handle large amounts of financial data, such as transactions, and as well as demonstrate things like SQL, embeddings, as well as some clusters. So at the front page, you're greeted with the recent spending by category. So we can check out that we have our spending split up by 7 different categories here. In our view, in a more tabular view, we can see that we can cluster by different categories here. If we maybe look at all time, so we can see we have about upwards of 3,864 transactions. So we're storing a lot of data in AlloyDB. If we look up maybe things like food, we can filter by office items, etc. So now let's take a look at the actual features that we implemented. So the first feature we implemented was the NL2SQL, which is a AlloyDB flagship feature. So this feature runs completely on AlloyDB. It was not coded. There is no Gemini API wrapper. It runs directly on the database itself. And as the name suggests, it is a natural language to SQL conversion. So I'd like to paste in a query and we can check out AlloyDB's response. So if I say something like show total spending by category, this query will be directly processed on top of AlloyDB, and it'll query our database and come up with the response for this query. We also added in a Gemini insight so the user could actually get some interpretability into their answer. So for show total spending by category, we can see the Gemini insight says household was our biggest expenditure at 120K. This is across all of the data, so that's why it's coming up with such large numbers. And we can even check out the generated SQL that it came up with. We can ask it other things like, for example, show me my most expensive purchases. And it should generate pretty quickly since the API should be warmed up. And yeah, so the Gemini Insight, again, brings up the top 10 most expensive purchases, which we can check out here. Now, the next thing we did was, since NL2SQL allows us to search over the database, but what if we wanted to search over meaning, right? Like, for example, I mentioned here like expensive purchases or spending by category, but what if I had something more abstract, like if I was looking for kitchen gifts or like things like coffee? So for that, we leverage AlloyDB's embeddings. And so that takes us to our next feature, which is semantic search. And so since we used embeddings here, we can now, rather than searching for direct matches, we can actually look up for things by their meaning. So as I mentioned, kitchen items and gifts, we can notice things like mother's kitchen spoon rest, blue breakfast cup and saucer, set of 3 cake tins. All of these things are related to kitchen gifts. And even though if they don't explicitly mention things like kitchen, if we search up something like maybe beauty and skincare products, we can see that our transactions are from places like Sephora, Bath and Body Works, and these seem to be pretty aligned with what the meaning is. Now, in this case, I guess we kind of knew what we were looking for, but what if we don't know, right? Like, what if I don't know the difference between like looking up by meaning versus looking up in the data? So for this, we created a new feature called Insights. And what Insights does is it has an agent which listens to our query, and then it uses an MCP server which we built underneath, which allows it to route queries to either the semantic search tool or to the NL2SQL. So this way, we don't necessarily need to know, oh, this is a question that requires meanings. We can just kind of send the query and then let the model figure it out. So if I ask something like, how much did I spend on hobbies? Since this is a question that we can actually use over query over structured data, it should route to the NL2SQL tool. And we can notice that it returns the SQL that it ran, as well as the result, which was about $16,000. Now, again, if I maybe wanted to like send another question, like things similar to my coffee purchases, this should run the semantic search since it uses embeddings. And we can notice here the semantic search works beautifully, decorative vintage coffee box, coffee caddy, etc. So now we can take a look at semantic clusters. And so similar to semantic search, which allowed us to query by meaning, this allows us to visualize our data by meaning. So if I maybe look up the last 3 months and create 5 different clusters, this will now query all of our data in the past 3 months and separate it out into different clusters by meaning. So we have a spending snapshot. So it explains things like how much I spent on maybe home furnishing, sweet scented decor, fashion accessories, and then paper goods. So if we pull up maybe the paper goods example, we can notice the tabular view, and it mentions things like lavender gift wrap, wrap green pears, a pretty thank you card. So we can notice that these things are aligned with what their meanings are. And we can maybe look at the fashion accessories. So maybe a necklace, another necklace, a bracelet. So we can notice that the semantic clusters also work very well. The last thing we implemented was a monthly report summary. So what this allows us to do is maybe over the large amount of data that we have, let's actually query it and try to see what kind of insights we can gain from that data. Can we maybe save some money? Where exactly did we spend all of our money? How much should it cost? So this specific feature allows us to query all that. So currently it's generating the May 2026 report, which it just did. And we have a nice view here as to how much we spend, how much we could save. We have some actual items here as to maybe things that we can do to reduce our spending. We can take a look at the spending by category, as well as some of the top merchants that we've spent money on. So this concludes all the features that we implemented as a demonstration of AlloyDB, but maybe let's take a look at the performance, right? So if I type in performance, we are then taken to this Grafana style dashboard, which demonstrates the backend, right? So how much latency, how much time was it taking for these calls being made? So we have all these different metrics here to measure. So we measured things like the time it took to route the MCP server, how much time it was taking for our Gemini calls. We have some graphs here to visualize the load that we were putting onto the database itself, and some more metrics here that we can check out. If you would like to take a look at the code is pushed to the Google Cloud Platform AlloyDB Omni Samples repo, so it would be right here. And if you want to maybe take a look at the original repo and see kind of how our contributions were made, sort of what our design process was like, then you can take a look at the original repo. I'll link both of these in the comments below or in the description below. And I also will link our final deliver slides. That way you guys can take a look at sort of what we were able to present. I'm really thankful for this opportunity and thank you so much for watching.